Hey guys, today we're going to be solving friction problems on rough inclined planes. So we have a particle of mass 2 kilograms sliding down a rough slope that is inclined at 30 degrees to the horizontal. Given that the particle's acceleration is 1 meter per second squared, find the coefficient of friction between the particle and the slope. So we're going to start by labeling all the forces on the diagram. So if the particle's mass is 2 kilograms, then its weight is 2g. And we have the normal reaction force acting perpendicular to the slope. And if the particle is accelerating down the slope at 1 meter per second squared, then that means friction is acting in the opposite direction, so it has to be acting up the slope. And in order to solve this problem, we're going to need to resolve forces perpendicular and parallel to the slope. And we're going to use the equation F equals ma. So if we start by resolving perpendicular to the slope, so in this direction F equals ma. So we have the normal reaction force, which we already know is perpendicular to the slope, but we also have in the opposite direction the component of weight that is perpendicular to the slope as well. So if I draw a dotted line perpendicular to the slope, and if I extend this to become a triangle, then this angle right here is always the incline of the plane. So in this case, that's 30 degrees. And so using SOH CAH TOA, this means that the component of the weight that is perpendicular to the slope is 2g cos 30. So the sum of the forces acting perpendicular to the slope is r minus 2g cos 30, and this is equal to ma. So the mass is 2 kilograms, and the acceleration is in fact 0, because the particle is not accelerating perpendicular to the slope. So if we rearrange this for r, we get r is equal to 2g cos 30. Now if we do the same thing parallel to the slope, so we're going to do F equals ma parallel to the slope. Actually, let's do it in the opposite direction. Let's do it down the slope. Then the force going down the slope, where we have the component of weight parallel to the slope, so that's 2g sine theta this time. And we have friction opposing it. So 2g sine theta minus friction is equal to ma. So the mass is 2, the acceleration this time is 1 meter per second squared. So 2g sine theta minus f is equal to 2 times 1. Sine theta is a half, which will cancel out with the 2. So we get F friction is equal to G minus 2. And now that we have friction and we have the normal reaction force, there is one last equation that we're going to need to use, which is F equals mu r, where F represents the friction, or the maximum value of friction, mu is the coefficient of friction, and r is the normal reaction force. So mu is what we're trying to find, the coefficient of friction. So mu is equal to F over r, which is g minus 2 over 2g cos 30. So if we take g to be 9.8, cos 30 in degrees, that's going to be root 3 over 2. So this comes out as 0.46 to 2 sig fig. So for this problem, we have a particle of mass 4 kilograms being pushed up a rough slope by a force of 20 newtons acting at an angle of 15 degrees to the slope. The resistance due to friction is 10 newtons, and the particle moves with constant velocity, so find the incline of the slope. So we're going to begin by labeling all the forces on the diagram. So if the mass of the particle is 4 kilograms, then its weight is 4g. And we also have the normal reaction force acting perpendicular to the slope. We've been told that the resistance due to friction is 10 newtons, and since we know that the particle is being pushed up the slope, then friction has to be acting in the opposite direction, so therefore friction has to be acting down the slope. And finally, since we know that the particle is moving with a constant velocity, then we know that the acceleration of the particle has to be 0. So now that we've got all the forces on the diagram, the way that we're going to find the incline of the slope is by considering the forces acting parallel to the slope. And again, we're going to use the equation F equals ma. So we're going to be using F equals ma up the slope. So the force driving the particle up the slope is the component of the 20 Newton force, which is parallel to the slope. So if we think about this as the right angle triangle again, then the component parallel to the slope is this component right here. It's adjacent to the angle 15, and therefore because it's adjacent, we're going to use cos. So 20 cos 15 up the slope, and then the two forces going down the slope, we have the 10 Newton force from the friction, and we also have the component of the weight, which is parallel to the slope as well. So let's draw the triangle again. This angle right here is theta. And the component parallel to the slope is this component here, which is opposite the angle. So the component is 4g sine theta. So the sum of all the forces parallel to the slope is equal to ma. So the mass is 4 kilograms, but the acceleration is 0. And so now that we've got this equation, we can rearrange this for theta. So 4g sine theta is equal to 20 cos 15 minus 10. Therefore, sine theta is equal to 20 cos 15 minus 10 all over 4g. So we're going to take g to be 9.8. And so this number comes out as 0.237 and so on. And so in order to find theta, we're going to take the arc sine of this number right here. So theta comes out as 13.8 degrees to 3 sig fig. Hey guys, thanks for sticking around. If you got value from the video, then smash that subscribe button and I'll see you next time.